Good morning, everybody, and welcome to Let's Talk FM. Following on from last week's successful show about air quality and some of the questions that came afterwards, today we are diving into sort of more the practical process of improving air quality. And for that reason, I welcome Adam Taylor from Spire Building Services. Welcome, Adam. How are you today?
Yeah, very good. And yourself?
Yeah, brilliant. Thank you. Adam is an expert in this area, and we've had a couple of discussions offline, which I thought was really interesting. And one of the goals of our show is to give FMs practical information, as well as top line conversations around the reasons why. And that's why it's really good to have you on. So I want to dive straight in, and I want to talk and get some of these myths out of the way. What are you currently seeing that you feel is or know is being missold to FMs and businesses across the world to create good air quality, but also currently to combat COVID-19?
Yeah, well, inevitably, being in the field of air quality, you follow a lot of people on social media. So I see what the various different companies, their twist on how they can help out with the COVID situation. So everyone's got an angle, and there's some good advertising out there that's clean, but some of it is a bit unscrupulous. So one of the first things I think is to look at the things that you can do for your building that really affect COVID rather than are just good practice. So emergency ductwork cleaning was one of the things that I'd seen people promoting. If we had a problem with mold or bacteria in the duct, that can proliferate and grow in the duct. Whereas with a virus only propagates itself inside a host. So by cleaning the ductwork, you're not reducing the amount of virus that's going to be transmitted. I'm not saying don't clean your ductwork. It's very important to do that. And if your ductwork is so clogged that you're reducing the cross section of it, then you've got a problem. And also, if you're increasing flow rates, then there's a bigger chance of anything in the ductwork being resuspended and put into the place. But the first thing to take note of is that the virus only propagates inside a host, so it's not going to grow in your ductwork. Another place where things like to grow, filters. I see lots of filter manufacturers mostly posting good information regarding what sizes of particles they can capture. But the thing to remember is, unless you have a recirculation system where you're bringing back contaminated air from the space, where it would be worth upgrading the filters, if the air handling unit had the capacity, there's no point in increasing the filtration grade on the outdoor air that's coming in. The virus has been found outdoors, and there's been examples of where it's actually been found on air pollution. So you could argue that, it's on air pollution, so therefore it could be brought into the building. But the likelihood of that is very low. So if you just have a dedicated fresh air system, there's no point in upgrading that filtration to deal with COVID. It's good to have a high level of filtration from a pollution point of view, particularly if you have high levels of particulates where your building is. But in terms of reducing the ingress of the virus from outside, it's going to make virtually no difference at all. And then one of the crazy things that I've seen is these special walk-through tunnels that they're putting outside of buildings, and people want to show that they're doing something, and there's a requirement to reassure people who are using these buildings and say, look at this tunnel. This is an anti-COVID tunnel of some sort. So some of them will blast you with UV light briefly, but one of the ones I've seen, there's always a marketing twist on it. But when you look down into it, with this particular one was spraying hypochlorous acid onto people who were going into the building. Now, yes, hypochlorous acid as a surface disinfectant, great, but as a surface disinfectant, it's not something that you want to be spraying on someone's body. And I don't think if it said acid spray tunnel, then people would really be particularly interested in walking through it, even if it did get rid of any COVID deposits on there. So.
Yeah, I mean, we've done a little bit of research into these tunnels, and yes, they well, one, let's be perfectly honest, no one wants to be sprayed with what's being sprayed out of them. You know, I don't believe there's been enough research into what it will do to the human body. And people are jumping on a bandwagon because the minute you walk past, you cough, you sneeze, you recontaminate the area if you are infected in the first place. I mean, it's an instant moment that you might disinfect something that's on clothing or on some form of personal belonging. But yeah, these are all interesting ones. I mean, yeah, ductwork cleaning is absolutely important to support fresh air and the air movement and everything else. But as you rightly say, it's going to have very little impact on dealing with COVID-19 coming into sort of your building or being transferred through the building. It's just good practice. So yeah,
it's very important, but it's definitely not an emergency measure you need to do now, unless maybe you haven't cleaned your ductwork for 10 years, but then there's probably plenty of other problems. So.
Yes, yeah, and I would agree. And it's something that airflow has been really brought into the light through this period of time. So as an example, you know, we spoke last week about extraction areas. Do they have an increase? Could they have an increased level of contamination because that's how the air flows? And should we be sort of protecting those areas away from sort of moving people away from them, so they're not sort of downstream, as I would call it? And then I've noticed all of these screens going up, various different sizes, and some are absolutely huge. And you know, from a layman's point of view, I look at that and go, is that going to be affecting the airflow? You know, how is that going to be sort of pocketing the air within the building? And how does the ventilation system that's so important work around those objects? I mean, do you feel that they're going to reduce the airflow and maybe possibly increase the risk of an office?
I mean, the most common office ventilation and HVAC design, because it's compact, is just dedicated fresh air feeds pointing at the back of a fan coil, and the extract system is kind of an also ran. It's not really part of the design. The primary role of the HVAC system is to make people comfortable, to have low air movement and small differences in temperature across the space. So if you have a typical fan coil with a number of ducted diffusers coming out of that, a normal building isn't set up to achieve much crossflow particularly. So I don't think putting up screens will make a massive difference. We saw the old what was the term for them? I don't know if it was meerkat offices, but just where everything is divided into little cells. It was never a problem when we had those. So I don't think putting up a screen in an average UK office is going to create a problem with the airflow. If your building is specifically designed to move the air across, and you've got rather than a single point extract, you've maybe got supply on one side of the space and extract on the other, then maybe to some extent it would create a problem. But I don't see it as being a problem. But I think maybe a more efficient way of looking at it would be to arrange the desks differently, so that people aren't, if you had two people directly opposite each other before, then you've got a real problem with air coming backwards and forwards. I saw a revised seating layout on a plane, and they just turned the middle seat round so that person was then the majority of the particles that they're emitting were going forward. So I think there's more efficient ways of doing it in an office than putting up screens, and that does seem, for somewhere where you go in every day, that's not a great environment to be in. I mean, I popped to the co-op last night, and they've got screens there where people are serving people, and reception desks. It's a perfect solution because you've got lots of people coming to visit that poor person at the desk and talking to them probably quite loudly, which increases the amount of particles that you emit. So that's a great solution for that type of environment. But I don't think it's the right thing to be doing in a typical open plan office environment.
So I think the great thing from there is as long as it's in your hierarchy of controls at the right level. So it's not a go-to. Office design, redesign, distancing, space is the key. But if that can't be achieved for any reason, as you talk about in reception areas, then you can introduce a screen. Absolutely makes a lot of protection and a good choice for the person in that working environment. But it should only be put in a last resort, really. So I think this is kind of building for me the pictures of processes that people should be going through when they're walking into the new office. So, I mean, we talk about trust being absolutely key to get people back into the workplace, and screens aren't necessarily going to build trust. Just saying that we've done things aren't actually going to just build trust. It's how you've gone through the process to come up with the measures that you're introducing. So, this is where air quality comes in and is really important. How do we test current air quality within the workplace, and how do we sort of start that benchmarking exercise to understand where our office sits?
Yeah, it is very important. A lot of office ventilation systems, it's just constant volume, and then the temperature is being measured because that is what people make the most complaints about. So in a lot of offices, particularly older stock, you may not be measuring anything. You may be measuring CO2 if you are doing demand control ventilation for that. But commissioning an air quality survey, either a point in time one to measure it for a week to see what you've got, or maybe some ongoing monitoring is a great solution for this. And you need to decide whether you're going to make that available to your employees or not, because you can do something in private, but something that's really reassuring is if you do an air quality survey and you do something about the air quality, and you can show people that it's up to a really good standard, and when they enter the building, there's a screen maybe that says, look, this is what the current air quality is like in the building. People walk into the building, they're like, okay, good, I'm safe, and they get on with their day. Whereas if they go to their desk and there's some black and yellow tape on the seat next to them and there's a plastic screen in front of them, it's always on their mind. And we've done so much in buildings to improve productivity. You just need to make people confident that the building is safe at the beginning, and then they get on with their day. So poor air quality has been shown to increase the risk of transmission. One of the primary things that's been noted is if you've got very low humidity within the space, these large infectious droplets, which is why we're all being asked currently to stay 2 meters apart, if you've got a warm, dry environment, those droplets can dry out very quickly, and then they become much smaller, and then they can hang around in the air for longer. That's when it becomes airborne. So keeping your humidity above 40% is ideal. Not a problem for the summer particularly, but in the winter we do see humidities dropping below 20%. So, but you need to know that. There are another thing. I mean, if you measure VOCs and also carbon dioxide, you've got an idea of the kind of air exchange rate you're getting, and I can see it might be that instead of stating how many people we need in the space, I think we want a movable target that says, right, you can have this number of people or this level of CO2. So say you can, or this level of VOCs, to say, right, we're making the air clean within the space, therefore we can have more people. Because I mean, space is like a cinema. How is that ever going to operate on profitably on a 2 meter spacing? Whereas if they can say, right, well, because of the type of ventilation system we've got, high flow rates, people are safer, so we can increase that density. But yeah, you've got to measure it first.
That's got my mind racing all over the place, because when we were talking the other day about desk booking systems, and people being able to book desks and knowing that they've been cleaned and ready for them to occupy them, they know when there's one available for them to sit in. And also, if you overlaid the air quality onto that system as well, that said actually the air quality now is at its sort of, I guess, peak capacity. If we go over these amount of people sat within this area, we're going to start producing poor air quality. So we're going to take away all of the rest of the available desks. So you're overlaying a whole number of controls that will give people absolute certainty that they're walking into a space where it's clean, they've got social distancing, the air quality is being monitored, and actually, if we're tipping the balance between anything, the space is taken out of use. And that, for me, is usable technology to push us forward, not just to combat our current situation, but also just to create a really smart, safe working environment for people. Yeah, I'd love. Yeah, it'd be great to just be able to combine all of that together and see if the cost and the model of that. It's just got my mind racing with some exciting thoughts that would really create a safe office place today and in the future. Yeah, one of the areas that I've not really had much impact in is sort of air movement modelling within an office. And whether that's something that we should and could be doing, and if it is something that has a positive impact or negative. I mean, because we just talked about being downwind from where the air travels, and we've, through some history of planes and other offices, we find that people sit in certain areas get infected with colds and flu if it comes into the office more. Might be a complete myth, by the way. Is there anything that we should be looking at about air movement modelling within our office spaces, or is it just not that important?
It is super important, air movement within a space. If you look at critical environments like clean rooms, operating theatres, aeroplanes, you use large volumes of air, and the direction of the air is very tightly controlled. So in operating theatre, you've got laminar flow coming straight down from the ceiling, and any contaminants that come off pass down to ground level and then away. And the same with airplanes. They say, I don't fancy going on an airplane, but it's one of the safest indoor environments you can be in. But that's all very well, but I don't want to be in an indoor environment with two people sat either side of me for 8 hours. That's too much. But if you're going to model the airflow in your office, you've got to be ready to change it, because it will not be set up to control airflow. It will be all about comfort and reducing complaints. If you really want to do something about it, and I think we're in a stage now where people are trying to work out if they can get away with doing nothing, as people are slowly coming back to work. So people are keeping an eye on the R venue, but you probably have to completely change the way your ventilation system worked, so that you were introducing clean air to the people and then exhausting it somewhere else. I mean, there's a concept of personal ventilation, which gets credits in well, where you use a much lower volume of outdoor clean air, and you supply that directly at someone's face, so they're kind of shielded from the effects of the rest of the room, which is a great solution. If you had a building that had that type of ventilation system, you wouldn't really need to do anything in a COVID scenario, because it's like wearing an oxygen mask. You've got that clean air coming directly to your face. But we could do offices differently, but we don't at the moment. So at the moment, like I said, on average, the air is blown directly to the back of a fan coil. If you were to put in a high-level displacement system, I worked with these for years. So take your fresh air, put it into a textile diffuser, so that fits on the ceiling, run that down the center of the building. You can then, if your extract matches it, you could kind of zone the spaces, and then you've got safe corridors where you've got clean air coming in, and people can pass through those. And it's not just with the textile ventilation, it's anything that doesn't create induction. And all of the diffusers that are typically used in office environments use induction to slow the air down, to stop drafts. So if you want to model it, great, and it is very useful, but be prepared to change everything about your office vent design.
But if we're talking around creating great air quality, we're talking around, this probably won't be the last virus to hit us on a global scale, but we also have to look at seasonal flu, cold situations. They cause an awful lot of lost hours within the workplace, and we spoke last week about poor air quality and the impact that has. Do you, I know this is a bit off piece, but do you actually think that we are designing the HVAC systems within our office spaces incorrectly? Are we because air conditioning has been number one, yeah. Keeping someone cold is kind of or warm as such has been probably the only factor that really comes into it. And we've seen the impact that's had, especially through this period of time. Are we getting it wrong from the start, and should we be looking at different ways of doing this?
Well, systems are generally built at a cost. If you look at the cutting edge buildings out there, they don't just have fan cores with fresh air blowing at them. You've got chilled ceilings, hybrid ventilation, lots of different things there. But generally, everything is done to squeeze as many floors into a building as possible. And the system that is generally used is extremely compact, and that's why it's used. But when you look at the wellness standards and the recommendations for airflow rates, they are much higher, and we're asking for greater air quality. Fortunately, Part F wades in on office ventilation rates and says, oh, you do actually need 10 litres a second per person. If they didn't, goodness knows how little air we'd actually be putting through office buildings, because it costs a lot of money to heat and cool and dehumidify air. So even with Part F, seeing the proposed regulations, the proposed changes to the residential version of it, there was a lot more talk about outdoor pollutants being removed from the air. So that's good. It looks like it's changing, but everything needs to be changed through regulation. There's only a few clients that will pay for an optional standard. I mean, BREEAM has got really good adoption, but a lot of locations, it's a requirement of the planning that you have a BREEAM accredited building. So we need legislation to force these changes, and it might be that legislation can force changes on existing buildings. At the moment, it's just advice, and forcing legislation through costs lots of money, and people don't want to be spending money at the moment if they don't have to.
So in lots of ways, if you're starting to create a new building and air quality is high on your agenda, you should be really sort of looking at how that is specified, how you're going to program that in, and the cost of getting good air quality. And I guess that comes in to what should the air changes and flow rates be in a workplace, and how can the viewers find out more and then compare those to obviously their current working environment?
Yeah, I mean, if you have a look at leading building standards, so AirRated, the WELL standard, and have a look at what they're recommending in terms of airflow rates, levels of VOCs that you should have in the space, and compare that with what you measure on your own site to see how far you are away, or hopefully your building is compliant with those higher standards. But have a look at the leading standards, which were pretty niche. And maybe just for the most expensive buildings going up there. But a lot of the ways a lot of people are working is, rather than getting these quite expensive certifications done, they're building the buildings to that standard and then not getting the certification. So these standards are very open with their information. So check out those. And then TM40 as well, released by CIBSE, has got a lot of useful information there. And CIBSE have an air quality working group, and they, before COVID kicked off, they were going to be releasing a series of pieces on air quality. So the first one was about VOCs, but it is useful to say it talks about how technology and sensors works, and whether all VOCs are bad, because some in very small concentrations are really bad for you, and some in very high concentrations don't matter. So that will give you a useful understanding as well. That's the CIBSE guidance.
good. And we're hearing a lot of it. The IAQ as an acronym that's sort of banded around. How do the viewers get to understand it, and how do we, I guess, identify areas that are high in IAQ, and also, if we do find that area, what are the things that we can do about it?
Yeah. So yeah, again, goes back to monitoring what you've actually got in your space. Now, certainly with AirRated, they measure 5 parameters. We've got carbon dioxide, VOCs, particulate matter, temperature, and humidity. There are other gases that need to be considered as well. So if you've got high levels, if you're near roads, high levels of nitrogen dioxide, soft dioxide, carbon monoxide, and ozone. So those need to be looked. Those need to be looked at as well. But in terms of what you can do, it's very location specific. So if you have high levels of nitrogen dioxide and sulfur dioxide outside, then some sort of gas filter could be applied to the air handling unit if you've got the capacity in the unit to deal with that. But again, with these gas filters, and sort of want to touch a little bit on portable air purifiers as well, something that works for the first few days and few weeks. You need to think long term about these things, because people are used to filters lasting a long time. But if you use a basic carbon filter in an area with high levels of pollution, be that VOCs or nitrogen, NOx and SOx, as they call it, it's going to become saturated very quickly. So you're doing something well-meaning, but all you're doing is you're introducing a pressure drop, and then these systems are going to be very quickly saturated. So there's newer technologies out there, and there's chemical adsorption rather than absorption, and catalyst technologies that are a little bit expensive, more expensive than a carbon filter, but will last many times longer. So there's a big rush in those technologies. So that's something that's worth looking at.
Yeah, we've used I've used a carbon filter in a certain process before, and it was as a last resort, but it was lasting not even a week before we were having to change it. This was the process why we were going to go through the change in a much greater scale, but it was to impact the air quality very quickly. And it did work, but as you say, increased maintenance and ultimately would have cost more money than actually making the physical change to the intake to the building, which was put into the wrong place. I mean, one of the things is quick wins. We talk about technology, which is great. We talk about sort of monitoring and getting on those journeys, which I think is the right thing to do, because you shouldn't be making any purchases until you understand what it is you're trying to rid the building of, or the improvements that you're trying to make. But there's quick wins that everybody can do. What are those quick wins in your mind, and are they affected by sort of the outside air pollution coming in? Because if you're in central London, it's going to be, in my mind, is slightly different to being in sort of a leafy countryside, as an example.
Absolutely, yeah. I mean, when you start measuring air in buildings, you can see the things that influence the air quality very quickly. Like, when do your cleaners come in? So if your cleaners are in 7 till 8, they are stirring up loads of particulates, they're spraying chemicals around, and then people are then breathing those in for the rest of the day. If you get your cleaners to come in 7 o'clock in the evening, when most people are gone, then you're exposing people to much less pollution. So very simple things like that are quite important. Another thing, again, have a look at how your system is working. So if you're running the ventilation system 24/7, it's unnecessary. Run it for an hour or so after people go, and then shut it off. There's no point really, other than for the control of VOCs. But yeah, maybe turn it on slightly before people come in, maybe at a reduced rate. But learn what your building's like. If it's chucking out loads of VOCs, then you will need to bring the air on earlier to dilute those, or use a technology that gets rid of the VOCs. But in terms of the outdoor air quality, I think we need something a bit more sophisticated. So when I'm in control of the ventilation in my house, if I know there's a big pollution event, I use a breezometer, and that brings in air quality data, and you can get a forecast on that. So if you look at a city centre location, the pollution that's generated by the morning rush hour is massive, and you don't get such a big peak in the afternoon. So if you can delay ventilating your building until after 10, don't delay ventilating it completely, and you need to be able to clean the air, but you have the potential to make your filters last so much longer if you're not sucking in that very worst air in the morning. So if you have the ability to recycle the air and to clean that air to make sure that's not posing a risk, if you can do that, and again, at the end of the day, when it's very, very hot, if you can bring in a level of recirculation at that point, if you're cleaning the air and it's not an additional risk, then we can save energy, we can save money on excess filter changes, and also the waste. What are we doing with all of these filters? You might be cleaning the streets of pollution very kindly, but yeah, we need to keep in mind on waste as well.
That's an interesting one, isn't it? Because yeah, we were just saying about turning the ventilation on earlier. If you've got the issue of VOX in there, so you can start circulating the air. It might then be in a high pollution area of rush hour. You can then turn that off for a short period of time. The worst of the rush hour goes by, and then you can restart at, say, 10 o'clock. So your people are coming in with a nice quality air. When they're coming in, it might worsen slightly through that period, but then you can speed that up, and it might save, as you say, on filter change cost, energy consumption, all sorts of different things. So it goes back to that whole thing, doesn't it? Of understanding what your building does, what's around it, where it's located, what works for you, and that goes back to testing and monitoring. And that's where it comes in, you know, because I've seen some technology that again is probably being pushed a little bit more at the moment, you know, to combat viruses and pollutions in air. And UV, what has come up a couple of times with myself and people asking the question through LinkedIn. You know, what are your thoughts of technology line? We'll stick with UV, but what is your thoughts with UV at the moment? Is it something that we should be investing in? Is it or is it again probably one of those myths that's kind of been banding around?
Yeah, I mean, UV has got really high adoption in the States, so they make a lot of UV systems there, and in the leading wellness building standard, UV is mentioned. I was at the CIBSE HTM 03 thing talking about healthcare ventilation, and we're putting UV forward as a solution for hospital environments. But these are critical environments that we're talking about, and a UV system that is typically installed is to keep the coil clean, and to keep the drain pan free of nasties, so that it doesn't pose a risk. That's what UV systems are typically used for in buildings, and that is a great solution. It reduces the maintenance on your coil, keeps the coil clean, keeps it efficient. It's a great solution. If we're moving to induct UV systems, so if you've got a recirculating system and you've got an induct system, you need to give a lot of energy to the virus as it's passing through to destroy it. And a system that is typically deployed on a coil isn't designed to do that. It's designed to put the UV light on the coil permanently, not to destroy something as it very quickly passes through. So I think there's probably a bit of mis-selling going on out there, and saying, oh, or this UV system will do this. I work with a very reputable UV company, and they haven't changed their marketing message because of COVID, because they do total coil disinfection. That's the product that they do. They're not saying, oh yeah, coronavirus, we do this. And the other thing to think about with the UV is, to get that pass-through kill, you're using so much electricity. And aside from destroying that virus, is it adding anything else to the air quality within that building? And in an office environment, do you need a 99.99999 kill rate on viruses as it's passing through? Is that an appropriate use of electricity, technology, and funding? I mean, these types of systems where you need that kind of protection are places like operating theatres, where if someone picks up the tiniest infection, then that can be really detrimental to them. And we have to go back to money as well. If that person is then having to be retreated again, spends a lot of time in hospital, then it pays for itself. But yeah, to try and get that 99.9% kill rate, it's probably not the best use of your money.
Okay, so I mean, one of the things we've talked about is sort of redesigning buildings. The other things we've talked about is buildings that probably have been built in sort of the near past, I would say. Not all buildings are like that, and not all buildings can have a lot of technology placed into their ventilation systems. I mean, what we briefly touched on it, but what technology can we use? So say we've done everything we've said. You know, we've gone through, cleaned all the filters, cleaned the ductwork, we've checked how the airflow is. It's its maximum capacity, but overall we're still not getting the kind of scores that we would like for good air quality. What can we do separately to that to give us a boost? And also, I think currently, is there a technology separate to all of our ventilation systems that we could add to the environment that possibly could help with the virus infection we're going through at the moment?
Yeah, well, I mean, standalone air purifiers are seeing a big increase in popularity. But again, you've got to, if we're talking about, let's leave the virus for a second, talking about using them to improve indoor air quality, you've got to select the right filter for the problems you have in your building. There was recently a really good review by WSP, and they looked at standalone air purifiers in schools in London. And a lot of these schools were selected because they had really high levels of nitrogen dioxide. If you put an air filter in, if it has a plasma system, it's got UV, it's got filters, but your problem is nitrogen dioxide, it's not going to do anything about that. You need to have a gas filter inside that unit. So you really need to get an understanding of what the filter is doing. The really serious filter manufacturers will give you lots of information about their product. The more, I don't need to use the word unscrupulous, but the more B2C products, which are more about how it looks rather than what it does and what the app interface is like, etc. You might have something that performs well on a test very quickly, but if you're buying a unit that has a couple of grams of carbon in it, it's not going to last very long. It will say carbon filter, tick on the box. You need something that's going to perform over a period of time. And the way these the products are going now is the clean air as a service model. So you rent the thing and you get your filters included for that, and the unit measures the air quality. So if you're measuring and you're putting your neck on the line and saying, right, we'll measure the air quality, we'll fix the air quality, and if your system needs more filters to keep maintaining that level of quality, we will send them to you, rather than just something you plug in and then you don't know what it's doing, and it's probably not doing a lot.
So again, it's understanding what you're trying to combat, and then picking a company that's an expert in that field, and again, I guess willing to make sure that they work with you to improve the air quality, rather than selling you a product that they think will improve your air quality. And this is why I think when you're going out into the marketplace at the moment, you've got to really look at the history of the business. If the business wasn't doing this work pre this virus, I suggest that you shouldn't be going in that direction. If they were specialising in air quality or disinfectant before this whole process, then they've probably done a lot of research, a lot of understanding, and hopefully are communicating in a much more reliable manner, even though we've seen some cases that go against that, unfortunately. I mean, want to just sort of finish off with, if I was going to be speaking to a contractor today that was about to start fitting out a building for me, know very little about HVAC systems and air quality and everything else. I mean, what is the kind of maybe 1 or 2 questions that you would want a facilities manager or a project manager to ask that person around thinking about the design of ventilation system?
What would I ask them to see what they want in a building, or what should they be providing me?
Yeah, so I think for me, it's what questions should a facilities manager ask the contractor to make sure the contractor's thinking in the right way, and not just going back and what we were talking about air conditioning earlier. What should be the primary focus of the question? I've got it in my head, but
well, you've got to ask the contractor, what do you think my tenants are interested in? What makes my tenant? Do you understand my tenants and what they want? Because what they wanted 10 years ago might be different to what they want now. And are they taking that into account, or are we just doing this because you've done that before and you've done that at a good price and you can do that, you can offer that efficiently? And make sure that they understand what the market wants these days, and they want transparency. We're going to have people going into buildings with air quality sensors on their phones, and demanding good air quality. And if you've got a standard system that's been fitted for the last 15 years, you're probably not going to deliver that. And people are more empowered, and they know what is good air quality and the risks associated with that. So, yeah. And the other thing is it going to perform on day 800 or just on day 1 to 10? Is this something that's going to keep delivering, or are we, like you say, putting in a carbon filter that then fails to deliver after a few weeks because it's saturated?
So if we're going to, a very difficult question, because again we're talking around sort of location where buildings are placed and external air quality's internal sort of design, but overall, what sort of would be the best sort of HVAC system that you think should be installed, or what should be the leading part of that system that's installed in within an office location?
Yeah, well, I spent a while working with natural ventilation. I'd love it if we could use natural ventilation a little bit more, and if we could keep the air quality that we had a few weeks ago before everyone started driving back to work, then natural ventilation would be fine in almost every location. But realistically, I don't know if that's going to be an option. It's always great if people can do that and they can have control over their ventilation systems. But if we're going to stick with mechanical cooling, maybe separate the cooling and the heating from the ventilation system, because you're always going to compromise how much air you can bring through a building if you're linking it to your heating and cooling system. So dedicated fresh air systems and things like radiant panels would be good from my point of view, and from an energy point of view as well.
No, couldn't agree more. A big fan of getting in fresh air into the buildings. I think we should be rethinking the overall design, moving away from recirculated air as much as we can do in certain locations. So thank you, everyone. Thanks for joining us today. Be safe, and we'll see you all next week. And Adam, thank you so much for joining us. It's great information there. Thanks a lot.
Cheers.